In the previous video, we learned about the second force that comes up over and over in this class, namely the tension force. The tension force is the force that a stretched cord exerts on an object attached to one end of the cord. So in this class, we're going to continue learning about how tension works. Now, one thing we're going to be using in this video is the force scale. We're actually going to be using two of these. The idea is that the force scale tells you in units of newtons the strength of the force being exerted on the hook down here. Right? So right now, the force scale is telling me that a 2 Newton force is pulling down on the hook. Now the force scale is telling me that there is a 4 Newton force pulling down on the hook, and so forth. Okay. We're going to do an experiment now where we have two force scales connected by the same string. And I'm going to start pulling on the force scale that I'm holding in my hand here. And right now, the force scale is telling me that there is a 4 Newton force being exerted on the hook. So that 4 Newton force being exerted on the hook would be a tension force. That tension force is being exerted by the string here, pulling the force scale towards your left. Okay. Now, you can probably see that at the same time, this end of the string is exerting a 4 Newton force on this force scale, pulling to the left. I hope you're seeing on the other force scale that the string is exerting a 4 Newton tension force. Oh, there we go. So I hope you're seeing that that at the other end of the string is exerting a 4 Newton tension force, pulling towards your right. Okay. Now, let's say I pull a little harder. So now you see that, well, according to what the force scale is telling us, this end of the string is exerting a 6 Newton tension force on the force scale to the left. And I hope you see at the same time that the other end of the string is exerting a 6 Newton tension force pulling towards the right. And you can see that no matter what I do here, the strengths of the tension forces exerted at the two ends of the strings are going to be equally strong. So I hope right now you're seeing 8 Newtons and 8 Newtons on both of the force scale, and now 10 Newtons and 10 Newtons on both of the force scales, and so forth, right? So whatever I do here in this experiment, the strength of the tension force that the string exerts on the scales at either end is going to be the same. Now you can ask, is there anything I can do to tweak this experiment so that I actually get different readings on the two force scales? It turns out that that's harder to do than you might think, but there is one thing I can do which definitely ends up giving me different readings on the two force scales, which is to grab the string and then pull on the string one way or the other. So let's say I'm pulling like so. Now you can see that there are very different readings on the two force scales, or I can pull the other way and you see again, very different readings on the two force scales. Okay, so again, if there's nothing grabbing onto the interior of the string, we have equally strong tension forces at either end, right? But if I grab onto the interior of the string, that's no longer true. So let's take what we just learned in this demo here, and I'm going to start writing this out on the board. So let's take the case where one force scale read 8 Newtons and the other one read 8 Newtons as well. The force scales are connected by a string, and what this is telling us is that over here at the left scale, the string is exerting an 8 Newton rightward tension force on that scale. So let's draw in a vector to represent that 8 Newton tension force pointing to the right. Okay, so here's a tension force, magnitude 8 Newtons. Okay. And then we also have a tension force that the right end of the string exerts on the scale over here, pulling to the left. Also 8 Newtons. Okay, So we have an 8 Newton tension force over here that the string exerts on the left scale pulling right. We have an 8 Newton tension force over here that the string exerts on the right scale pulling left. Now, in this situation, it is fair to say that we have an 8 Newton tension throughout the string. Okay. Now, notice here how I use the term tension force versus how I use the term tension. The tension force here and the tension force here, those are vector quantities which refer to the interaction between the string and one scale or the other. Okay, so tension force, a vector quantity which refers specifically to an interaction between two different objects, either string in the left scale or string in the right scale. When I use the word tension by itself, that is a scalar quantity, and it is describing a property of the string itself, not an interaction between two different objects. Okay, so vector quantities describing interactions, and then a scalar quantity describing a property of the string itself. The other thing I want to point out is referring to the demo from before, which is that as long as we have nothing acting on the interior of the string, as long as we have no forces acting on the interior of the string, we will have the same tension throughout the string, right? If there is some force that comes in and grabs on the string, then the tension can change. But as long as no forces come in and act on the interior of the string, then we have the same tension throughout the string. Okay? And in the next video, we will take the idea of tension, and that will be a launching point to go into the first major physics principle of the course.